Hello, students. Today I know you have attended Re-NEET and the paper level. How was the paper level? How was chemistry paper? Comment in the comment section so that I'll come to know how you have performed. Yes, answer fast. How was the paper? Was it difficult or easy? Chemistry paper? Okay, I'm audible also. The paper was easy. It wasn't very much difficult. So let's solve the paper, chemistry paper. I'll tell the answer and solve the answer for all the questions. If you have any doubts, and while watching also, you can comment the answers, whatever you have written. Okay. So let's start with the question. See the question. What's written? What is given there? Match the species in list 1 with their geometry in list 2. So here we have PCl5. We know the geometry of PCl5. What is the geometry of PCl5? It is trigonal bipyramidal. Okay, it is trigonal bipyramidal geometry. But in three options, we have same thing. So let's go to BRF5. In BRF5, what is the geometry? BRFI has square pyramidal geometry. In which one of the following option we have square pyramidal for B? So B corresponds to 4. That is in option A. So our option A is correct here. Okay, for question number 46, that is match the species in list 1 with that geometry in list 2. Which option is correct? Option 1 is correct. That is A corresponds to tri trigonal bipyramidal, B for square pyramid, C that is BF4 minus C is for tetrahedral. It has tetrahedral geometry, and last one complex has which geometry? Square planar geometry. Okay, so if you know how to solve already, like if you got the answer, then no need to go for the next one. Directly go for the next question. Don't check other options. Next, the amino acid that gives red blood color on treating its sodium fusion extract with sodium nitroprusside is. See, why do we use sodium nitroprusside test? Sodium nitroprusside test is used to detect sulfur. 1 minute. Sodium nitroprusside test is used to detect sulfur. So, sulfur containing compounds which are present will form Na2S. Sodium sulfide formation takes place in sodium nitroprusside test. And this sodium Na2S reacts with sodium nitroprusside. This react with sodium nitroprusside to form red violet color or blood red color compound, or blood red color formation takes place. So among the amino acids which are given here, in which one we have sulfur? In methionine we have sulfur. So methionine is the correct option. Okay, is it clear? So which is the correct option? Methionine is the correct option. I hope you got this one. Next, what we have, which is the next question? Question number 48. 1 minute. Yeah, read the question number 48. Which is the correct option for 48? Read the question. Okay. See, it's given that oxidation of para-nitrotoluene, oxidation of para-nitrotoluene with acidic KMNO4 gives an acid that is stronger than benzoic acid. See, oxidation of para-nitrotoluene. So para-nitrotoluene will be converted into para-benzoic acid. We have para-nitrotoluene. This para-nitrotoluene on acidification, on treatment with acidic KMNO4, right? On treatment with acidic KMNO4 produces para-nitrobenzoic acid. So NO2 is strong electron withdrawing group here in para-nitrobenzoic acid. So because of that strong electron withdrawing effect, the acidity increases. So this option is, statement 1 is correct. Now let's go to statement 2. What is given in statement 2? Reduction of para-nitrotoluene with tin and HCl followed by neutralization. So here followed by neutralization gives amine that is more basic than aniline. Yes, this is also true. So CH3 group, it's a electron donating group. We get CH3 group over there, which is electron donating, and it will become more basic than aniline. So that's also correct option because of that's plus I effect, so which increases the electron density. Because of increase in electron density, it will be more basic in nature. Amines are more basic than aniline. So both statement 1 and statement 2 are correct. Which one is correct option then? Option 4 is correct for this question. So next let's go to question number 49 here. In question number 49, check the answers. Check first, let's see the question. The standard electrode potential for a half cell reaction is given for conversion of Fe plus 3 to Fe plus 2 at 298 Kelvin is. So few details are given here. E naught of reduction is equal to plus 3 to Fe is equal to minus 0.04 volt, and Fe plus 2 to Fe is minus 0.44 volt at 298 Kelvin. So what we have to find? We have to find the standard electrode potential of the half cell. See, here for conversion, it is the values are given, the potentials are given, and what we require the standard electrode potential and E naught, that is Fe plus 3, which accepts electron to form Fe plus 2. So this is required for us. First, we know the formula delta G naught is equal to minus NF E naught. Okay, so this is the formula we have. So delta G naught is equal to minus NF E naught, and from the data which is given in the question for first one, if I calculate delta G, I'll consider that one as delta G1 naught. We have how many electron transfer? Total 3 electron transfer. Minus 3 into F, which is F is Faraday, considered as it is. E naught value is given minus 0.04. So this is nothing but how much do we get? 0.12 Faraday F, and delta G2 naught is equal to how much we are getting? 2 electron transfer is taking place here, plus 2 to Fe, minus 2F into minus 0. It's 44, which is equal to 0.88 Faraday. Now, if I want to calculate difference between these two, what I get for the reaction, for the main reaction, for the required reaction, I'll get 0.12 F minus 0.88 F, which is nothing but minus 0.76 Faraday. Now, I got this value. So, calculate E naught. E naught is equal to minus delta G naught by F, because here N value is 1. So, that substitute, what is delta G naught? 0.76 minus 0.76 divided by F. So, how much value you will get? If you solve this, you will get the value which is equal to plus 0.76 volt. Okay, so in which option we have this? That is option A. That means option 1 is correct in this one, 49th question. This is how we will solve this question. Okay, now let's go to next question. The compound that cannot be obtained from aldol condensation reaction shown below is, see, aldol condensation is not given by the compound which do not contain alpha hydrogen. Here, in case of first compound, that is ketone, here I have two alpha hydrogen atoms. Two alpha hydrogen atoms are present, but when I consider this one, there is no alpha hydrogen. Since there is absence of hydrogen, so it cannot form, only with same compound it will not form aldol product. Remember this. So cross aldol product formation takes place always. So here, and we know aldol product alpha beta unsaturated aldehyde will be produced. Now check the options. See, here this is alpha carbon, beta carbon. I have alpha beta unsaturated one, unsaturation. And when I come to this one, here also this is alpha. 1 minute. Yeah, when I come to this one, this is alpha. Okay, this one is alpha and this one is beta. Here also alpha beta unsaturated product formation is taking place, and here also alpha beta unsaturated, but here there is no alpha beta unsaturation. So option 4 is not applicable here. This will not be formed because of aldol condensation reaction. Directly you can solve like this. Okay, next go to question number 51. Check question number 51. For a salt Xy, which is a strong electrolyte, the plot of lambda m versus root C has a slope of minus 90 Siemens centimeter square, mole to the power minus 3 by 2, liter to the power 1 by 2 at 298 Kelvin at 0.01 molar concentration of at 0.01 molar concentration of Xy, the value of lambda m is 145 Siemens centimeter square per mole. The limiting molar conductivity of Y minus ion at 298 Kelvin will be. So what and all is given here? Slope is given. Slope is equal to how much? Minus 90. Okay, that's given. Concentration is given. Concentration is equal to, what is the concentration? 0.01 molar, that's given, and lambda m is equal to 145. So this much things are given. So we know the formula root C. We want root C, and formula will be lambda m is equal to lambda m naught minus k root C. Right. So for this I want root C. Directly I'll calculate root C first. Root of 0.01, which is equal to 0.1. Now take this formula and substitute in that one. Lambda m, we know the value 145, which is equal to lambda naught m, that I don't know, into 90 into k value is 90, which is given in the question, has the slope that is given 90 into 0.1. 1. Concentration root C is 0.1. We have calculated that. So we get 145 is equal to lambda m naught minus 9. Here lambda m naught is equal to 145 minus 9. That is, you will get 145 plus 9. That is nothing but 154 Simon centimeter square per mole. Okay, so this is what we get. Now I got lambda m naught value. We know limiting molar conductivity of weak electrolyte is equal to lambda naught of cation plus lambda naught of anion, Y minus. Here, okay, so next we have calculated this lambda naught limiting molar total limiting molar conductivity, which is equal to 154, and 154 is equal to, and what about for x minus, it is it for, sorry, cation, it is given as 74. Here in the given it is that 74 plus lambda naught of Y minus. So rearrange this and calculate the value of lambda naught of Y minus is equal to, how much do we get? 80. That is 154 minus 74, which is nothing but 80 Simon square. Yeah, 80 we get, which is in option 4. So for question number 51, option 4 is correct answer. Okay, I hope you got this. Any doubt in this one? Any doubt? If you have any doubts, comments in the comments, comment in the comment box. One minute. Is my screen is visible? If it is not visible, please let me know. Is it blur? Okay, yep, it is visible. Now let's go to next question. '51 is over. Yep. Given below are two statements, assertion and reason. Assertion is the first ionization enthalpy of oxygen is lower than that of nitrogen and fluorine. See, nitrogen, oxygen, fluorine. We have three elements with configuration 1s2, 2s2, 2p3 for nitrogen, 1s2, 2s2, 2p, 4 for oxygen, 1s2, 2s2, 2p, 5 is for fluorine. Fluorine is the highest effect. Its nuclear charge is greater than 0 effective nuclear charge. It is very electronegative in nature. That's why we are not considering this one. So ionization enthalpy of nitrogen, first ionization enthalpy of nitrogen is greater than first ionization enthalpy of oxygen, and which is greater than first ionization enthalpy of, 1 minute, here. See, if I consider fluorine and oxygen, fluorine has higher effective nuclear charge than oxygen. Fluorine's effective nuclear charge is greater than oxygen. That's the reason why the first ionization enthalpy of nitrogen is greater than oxygen, and that is less for fluorine. Okay, so this is the reason. And here what is given? The first ionization enthalpy of oxygen is lower than that of nitrogen and fluorine. So assertion is correct. Let's check the reason. The loss of electron The loss of an electron from oxygen leads to stabilized half-filled p orbital. If it loses one electron, it gets 2p3, which is half-filled configuration, which is more stable. We know that. So both assertion and reason are correct. So which option is correct for this one? Option 4. Both assertion and reason are correct, and reason is correct explanation of assertion. So we can go with answer 4 for this one. Now let's go to next question. According to crystal field theory, the correct order of ligand, which is the strongest ligand, we have carbon monoxide. In two options we have that is option 1 and option 4, and which is weakest, that's also Cl minus and Cl minus same. Among NH3 and NH3 and H2O, which one is more stronger in nature? NH3 is more stronger. That's why option 4 is correct. So we can go with option 4 for question number 3. Next, come to question number 54. See, statement 1. FeOX33 minus is chiral in nature. So is it correct? Is it FeO33 minus is chiral? Yes, it is chiral in nature. Is it superimposable on its mirror image? It forms like bidentate ligands with type AA3. They form chiral compounds. So this is correct option. The statement 1 is correct. And if I go to statement 2, what is given? Trans CrH2O2 OX2 minus is chiral. So is it chiral? Which type of complex is this? It is trans. Remember, Cr will be at the center, H2O2 one side, H2O2 here, trans, and another one is bidentate ligand oxalato. Is it this one? This is the structure. Okay, sorry, this will be the geometry. Is trans is chiral in nature? No, it is not chiral in nature. So statement 2 is incorrect and statement 1 is correct. Option 2 is correct here in question number 54. Next, go to question number 55. For the following reaction sequence, choose the correct option. See, which reaction is given? Benzene reacts with CH3COCl, AlCl3, and then forms NaOCl. So in this one, P and Q are aromatic compounds. So which compound will be obtained in this one? Which reaction is this? Find the reaction. See, first one is acylation reaction. See, when we treat benzene ring with CH3COCl, when benzene is treated with CH3COCl in the presence of AlCl3, what do I get? C double bond O Cl. Acyl chloride formation takes place. When acyl chlorides are treated with NaOCl, NaOCl, what product will be formed? So this is one minute. Okay, when second step is treating acyl chloride with NaOCl. Here what do we get? P and Q are aromatic compounds. Is it true? Do we get both P and Q aromatic in nature? It P and Q. So what product will be obtained on treatment of acyl chloride, that is benzoyl chloride, with NaOCl? Which reaction is this? Comment in the comment section fast. Yes. Huh. Okay. So, sorry. When acyl chloride is treated with NaOCl, we get C6H5COO Cl. This product will be obtained. Okay. So, along with this product, if we are heating this further forms, this one C6H5Cl plus CO2. So the final product is C6H5Cl plus CO2. So now let's go to option. What is given there? P and Q are aromatic compounds. This is wrong. P gives carboxylic acid on acidification. Yes, this gives carboxylic and on acidification. Okay. And Q gives a poisonous gas on exposure to air and light. Both P and Q are carbonyl compounds. This is also wrong. And P is sodium salt of this is also wrong. So we have to go with. Yes, I hope the screen is visible now. Is the screen is visible? Yeah, let's continue solving the questions. Next is question number 56. Yeah, in question number 56, what is given for a elementary reaction? Yeah, for an elementary chemical reaction, the Arrhenius plot is given below. Arrhenius plot is given for ln K versus 1 by T. The energy of activation is 6.64 kilojoule per mole, and R value is given. The temperature at which the rate constant becomes E square minute inverse is. So how to calculate this? We know Arrhenius equation. Arrhenius equation is equal to ln K is equal to ln A minus EA by RT. Okay. Now here from this graph we can say uh, intercept, which is what is the intercept here? Intercept is ln A. Ln A is intercept, which is equal to 6. The data intercept is 6. We have ln A value is equal to 6, and given E activation energy, EA value is given, R value is given. EA value is given in kilojoules, so convert that into joules per mole. If I convert that EA value into joules per mole, what do I get? 6640 joule per mole we get. Okay, R value is directly given, we can take that one. Now what is EA by R? EA is 6640 divided by R value is 8.3. If you do this, you will get the value 800. Okay, now calculate ln K. Ln K is equal to 6 minus 800 divided by T. And what is given in the question? K should be equal to E square. So ln K is equal to 2. So we have, by taking ln on in this equation, we get ln K is equal to 2. So substitute in this equation. 2 is equal to 6 minus 800 by T, or I can write T is equal, which implies T is equal to 800 by 4, which is equal to 200 Kelvin. On simplification, what is the temperature that we are getting? 200 Kelvin, which is option 2. So therefore option 2 is correct for question number 56. Now let's go to question number 57. In 57, arrange the following compounds in increasing order of polarity. In increasing order of polarity, we have to arrange. Which are the different compounds present there? First one is here diethyl ether is there. One is alcohol, another one is dimethyl ether, and last one is carboxylic acid. We know carboxylic acid is highly polar in nature. So D is highest. In three options, we have highest D. And after that comes alcohol. Ethers are less polar in nature because of presence of same type of group on either side, but we can take that C double bond O. I'll take that first. First comes COOH, that is acid. D, then comes alcohol, that is op B. In these two we have B. Then so among 2 and 3, one should be correct. Among diethyl ether and dimethyl ether, which one is more polar? Dimethyl ether, because of presence of CH3 group over there. So which option is correct for us? The correct option is D, then comes B, then comes C, dimethyl ether, and diethyl ether. So option C is, third one is correct for this. Okay. Next, let us go to 58. A protein undergoes reversible thermal denaturation from its initial state N to denaturated state D. So N is getting converted into D. This is given at 60 degrees Celsius. The concentration of both N and D are equal at equilibrium. Okay, 60 degrees Celsius, concentration of N and D are equal. 60 degrees Celsius means if I convert this one into Kelvin, I'll get 333 Kelvin. Okay, next, at this one, concentration of N and D will be equal. So if concentration of N and D are equal, then equilibrium constant K is equal to concentration of D divided by concentration of N, which I get as 1. So we know the equation delta G naught is equal to minus RT ln K, which is equal to 0. This becomes equal to 0. So use this equation, delta G naught is equal to delta H naught minus T into delta S naught. Delta G naught is 0. Just we have calculated that, which is equal to the enthalpy change is 666 kilojoule per mole. Delta H naught is 66 minus temperature is 333 into delta S naught. So calculate the value of delta S naught by rearranging. Delta S naught is equal to 666 divided by 333, which is equal to 2. In which option we have? We have this in option number 4. Option 4 is correct for this one. Next, come to question number 59. Consider the following statements about the solutions formed by mixing two liquids. Okay, solutions are formed by mixing two liquids. We have to find which one is correct. An ideal solution thus formed obeys Raoult's law throughout the composition range. An ideal solution formed obeys, yes, ideal solution obeys Raoult's law. A is correct. Then mixture of chloroform and acetone shows negative deviation. This is also true. They form bond and they show negative deviation because of hydrogen bonding formation. Mixture of aniline and phenol show positive deviation. Is it true? No, aniline and phenol will show negative deviation, right? This one is wrong. So which one of A and B and C are correct? Only A and B. Option 4 is correct one. Next, question number 60. Again, which one is correct and which one is wrong, we have to tell. Heating NaCl with concentrated H2SO4 and MnO2 results in oxidation of Mn. See, when I treat NaCl with H2SO4, we get HCl plus Na2SO4. Now we have MnO2 also along with this one. When MnO2 reacts with this HCl, what do I get is MnCl2 plus Cl2 plus H2O. Here MnO2 is reducing from plus 4 to plus 2 oxidation state. Reduction is taking place. But here what is mentioned in question number 60? Results in reduction of manganese. Reduction of manganese is mentioned. 1 minute. Sorry, oxidation of manganese is given. Okay, oxidation of manganese is not taking place, that reduction of manganese is taking place, that from plus 4 to plus 2. Next, second one, heating NaI with concentrated H2SO4 and MnO2 results in reduction of manganese. Yeah, heating of sodium iodide with concentrated sulfuric acid. Since I minus is a strong reducing agent, it reduces, it is strong reducing agent. It reduces MnO2, which is present to Mn plus 2. Mn is reduced. So statement 2 is correct and statement 1 is wrong. It is in which option? It's in option 3. Statement 1 is incorrect and statement 2 is correct. For question number 60, option 3 is correct answer. Next, let's go to next question. Given below are two statements. Statement 1, trans 2-butene upon treatment with Br2 in CCl4 gives the following product. See, Br2 and CCl4, this forms anti-addition product. Okay, anti-product will be obtained. So here in the option given, Br on opposite side, that is in anti-positions. So statement 1 is correct. Now let's go to statement 2. One minute. Trans 2-butene. Yes, cis 2-butene upon treatment with alkaline KMNO4 gives the following product. With alkaline KMNO4, which type of product will be formed? Oh, with alkaline KMNO4, OH group will be attached to cis positions, right? So here they are on same side cis position. Statement 2 is correct. So in the light of the above statement, choose the most appropriate answers. So which option is correct in this one? Which option is correct? Both statement 1 and statement 2 are correct. Option 4 is correct. Now let's go to question number 62. The highest occupied molecular orbital in Ne2 is, if you write the electronic configuration of Ne2, total how many electrons are present? 20 electrons are present. 20 electrons means last electron will enter into which orbital? Sigma star 2p orbital. So option 3 is the correct answer. You will get sigma 1s2, sigma star 1s2. That molecular orbital configuration will be there. If you fill that, the final value will get electron is sigma star 2pz. Two electrons will enter into that orbital. So sigma star 2p is correct answer. Next question. The following carbocation is stabilized by interaction of empty p orbital with, see here, carbocation first is stabilized by resonance. In resonance, electrons will come from pi electrons, pi orbital. So here I have, in two options we have pi orbitals. Now let's go to this side. Here, which effect is observed there? Hyperconjugation. Alpha hydrogen is present, which forms hyperconjugation effect. Because of hyperconjugation effect, sigma electrons will move between carbon and hydrogen. Sigma electrons will be there. Those sigma electrons will move and they form hyperconjugation elect. So filled sigma and filled pi orbital. Option 4 is correct answer. Next question. The green paramagnetic species formed by heating KMNO4 at 513 Kelvin is, See, we are heating which compound? KMNO4. KMNO4. So if you heat KMNO4, it forms K2MNO4 plus MnO2 plus O2. So this green colored compound formed is nothing but potassium manganate, which is green in color. K2MnO4, potassium manganate is green in color. So which is the correct option? Option 4 is the correct one. Next, let's go to question number 65. The correct statement is beryllium has 3 valence orbitals. Is it correct? How many valence orbitals will be there? Sorry, beryllium has 3 valence orbitals. No, beryllium, the electronic configuration of beryllium is 1s2, 2s2. So it's not 3. Leave that, that's wrong. Then second one, magnesium has a maximum covalency of 4. What is the maximum covalency? Maximum covalency of magnesium. How many bonds it can form magnesium? Only 2 bonds, MgCl2. It can donate 2 electrons, right? So 2 bonds can be formed by magnesium. This is also wrong. And next one, aluminium has 5 valence orbitals. No, aluminium don't have 5 valence orbitals. How many electrons it can accept? Only 3 electrons. So that's also wrong. Boron has maximum covalency of 4. So this is correct. Question number 65, option 4 is correct one. Next question number 66. The correct statement about peptides and protein is, first one, only the proteins having a quaternary structure are biologically active. This is wrong because some tertiary structures are also biologically active in nature. And next, second one, in beta plated sheet structure, peptide chains are held together by intermolecular hydrogen bonding. This option is correct. Okay, so check other two options also. Anyway, we got this. We are moving into next question 67. Next question we have is, given below are two statements. One is labeled as assertion A and another one is reason. Generally, 3D transition metals have high melting point. Is it true 3D transition metals have high melting point? Yes, that's true because of unpaired electrons present in them. Reason, involvement of 3D electrons in addition to 4s electrons in interatomic metallic bonding. Yes, reason is correct for assertion. So both A and R are correct and R is correct explanation of assertion. Option 4. Consider the following schematic plots of orbital wavelength, that is psi r against distance r from the nucleus. The figure representing two radial nodal in the orbital is, what is meant by radial node? When the wave function becomes 0, that is called radial node. Check the graph in which one two zeros are present, two radial nodes are present. Here we have only one, here 1, 2 is that. So we are getting two radial nodes in this one. So option C, that is 2 is correct. Next. Identify the reaction which give aniline as the major product. Okay. When I treat C6H5Cn with lithium aluminium hydride, what do we get? Here C6H5CH2 NH2. It's a strong red lithium aluminium hydride is a reducing agent. I get C6H5CH2 NH2. Reduction of CN group takes place. Then if I treat B with, that is C6H5CONH2 amide with Br2 in the presence of KOH. So what do we get here? We, in this case, we get C6H5NH2, which was the question asked, answer for the question asked. Identify the reason which give aniline as a major product. So in this one, we get aniline as major product. In another one, nitrobenzene with sodium borohydride. So sodium borohydride cannot reduce nitro compound. So here there will be no product formation. And last one, is, yes, acetanilide on reaction with HCl. What product will be formed here? C6H5NH2. Here also C6H5NH2 formation takes place. So which are the correct options? In which one we get this? 1, B and D only. Only B and D gives aniline. Other two will not give aniline. At A we are getting C6H5CH2 NH2, not aniline. Alkyl amine formation is taking place there. And in C, there is no product formation because NaBH4 will not reduce NO2 containing compounds. Next, 71. Among the species given below, spin-only magnetic moment is higher for. For calculation of spin-only magnetic moment, we want square root of n into n plus 2, where n is number of unpaired electrons present. If I consider first one, that is FeCN6 3 minus, Fe is in plus 3 state, plus 3, Fe plus 3 is nothing but D5 configuration, and here we have Cn minus ligand, which is a low Cn minus is a strong field ligand. That means it has low spin. So in the presence of strong field ligand, how the configuration will be? Pairing of electron takes place. We left with only n is equal to 1 unpaired electron. If you come to second one, CONH3 6 times plus 3. Here cobalt is in oxidation state of plus 3, that is 3d6 configuration. So NH3 is again a low spin, and the configuration will become, number of unpaired electron will become 0 in D6. Pairing of electron takes place. Low spin means strong field ligand, which causes pairing of electron. When all electron gets paired, then there will be no unpaired electron left. Next, go to third one, TiH2O 6 times plus 3. So here titanium is in plus 3 oxidation state, that is 3D1 configuration. 3D1 configuration is equal to n is equal to 1. And last one is MnCN6 3 minus. In this one, manganese is in plus 3 oxidation state, which is equal to 3D4 configuration. Cn minus is a strong ligand which causes pairing of electron. So here what happens? How many unpaired electron will be present? 4 unpaired, sorry, it's a weak ligand which will not cause pairing of electron. So 4 unpaired electron will be there. Which one will be having highest value of N? Fourth one. 71. Fourth one, we have highest number of unpaired electron. And when highest number of unpaired electron is higher, magnetic moment will also be higher for that. Okay, now let's go to next question. The complex which has facial and meridial isomer is, see, vacant mer isomer is obtained by the complexes which have A3 B3 kind. See, here we have A and B, both are ligands. Here we have A3 and B3 type of complex, Ma3 B3. So option 4 is correct for this one. Go to next question. And 1:3 electrolyte in aqueous solution is 1:3. So 1 complex formation and 3 ion formation. So that occurs in option 2. So 3 chloride ions are present outside. So this will form 1:3 electrolyte. Next, let's go to question number 74. Yeah, in question number 74. Consider the reversible process. So they are forming closed cyclic reversible process like 1 to 2, 2 to 3, 1 to 2, 2 to 3, 2, 3 to 4 and 4 to 1 again. So for cyclic process we have delta U is equal to 0. Change in internal energy is equal to 0. So first, by using first law of thermodynamics, what do I have? Delta U is equal to Q minus W. If one complete cycle takes place, then net heat will be equal to work done. Here second process and fourth process are adiabatic in nature. So for adiabatic process, Q2 is equal to Q4, which is equal to 0. Adiabatic process heat change will be 0. And 1 and 3, these two processes are isothermal process. For isothermal process, in case of ideal gases, we have delta U1 is equal to delta U3. Internal energies will be equal for them. So total net change in internal energy around the cycle is 0 by applying W1 plus W2 plus W3 plus W4, which is equal to 0. In which option we have this one? That is in option 3, C. Next, in acidic medium, 10 ml of 0.25 molar oxalic acid is titrated with KMnO4 solution. If the volume of KMnO4 solution required to reach the endpoint is 10 ml, the strength of KMnO4 solution is. So we have the formula M1 V1 N1 is equal to M2 V2 N2. So we don't know the value of M1 into N1 is 5, V1 is 10, 10 into 5. which is equal to 0.25 into 10 into 2. So if you simplify this one, what do you get? M1 into 50 is equal to 5, or M1 is equal to 5 by 50, which is nothing but 0.1 molar. In which option we have this? Option 4. For question number 75, option 4 is correct answer. Yes. The lanthanoid ion with 4 unpaired electrons is HO plus 3. This has 4 unpaired electrons. Option 3 is correct for this one. Next question. The correct decreasing order of oxidation state of underlined atom in each molecule is. So calculate the oxidation number of each species present over that, and decreasing order is, which one is correct option? N2O5, N2 nitrogen is plus 5, aluminium plus 3 oxidation state. So and sulfur is in -2 oxidation state. So order is correct. Option 1 is correct here. Next question. Consider the following reaction. Which reaction is this? Itard's reaction. Itard's reaction. Compound P can be prepared by treating benzene with anhydrous AlCl3. No, P cannot be formed by AlCl3 with CH3COCl. That is Friedel-Crafts acylation. Acyl chloride formation takes place there. Not this one. Not benzaldehyde. On treatment with bromine water, compound P gives a white precipitate. No, that's also wrong. Compound P is obtained by hydrogenation of benzoyl chloride with palladium on barium sulfate. That's called Lindlar's catalyst. Yes, Lindlar's catalyst will form benzaldehyde. So option 3 is correct. Now let's go to next one. An ideal solution formed by mixing liquids P and Q, delta H mix is 0 and delta V mix is 0. Is it true? Yes, assertion is true, because in case of ideal solution, delta H mix and delta V mix will be 0. So no interaction occurs between P and Q in light of the above statements. Okay, no interaction occurs between P and Q. So interaction will occur between P and Q, but the interaction amount, PP interaction and QQ interaction will be equal to PQ interaction. So second reason is wrong. Assertion is true and reason is not true. It's incorrect. In which one we have this? A is correct, B is not correct. Option 2 is correct. Next, go to question number 81. Match the vitamins in list 1 with their sources in list 2. A corresponds to carrots, correct. While fourth one, A for fourth one, we have among these two, one is correct option. Vitamin B12 will be present in meat. So B corresponds to 1. So option A is correct. That's, sorry, option 1 is correct. Okay, next question. Among the following, the compound having conjugated double bond is, which one has conjugated double bond? Hepta 1,3 diene. Conjugated means one single bond, one double bond, which is present in hepta 1,3 diene. Next question. One of the product formed in the following reaction is, when Grignard reagent is treated with aniline, followed by hydrolysis, it should form cycloalkane. Yes, option 3 is correct for 83. cyclohexane formation takes place. Next question. 2 moles of an ideal gas solution, free expansion from 10 liter to 100 liter at 300 Kelvin. The values of delta S system and delta S surroundings are. Okay. So we know delta S of system is equal to NR ln V2 by V1. Okay. So what is given in the question? 2 moles of an ideal gas. That means N is given as 2 and V1 is given as 10. V2 is given as 100. 10 liter and 100 liter. Okay. Now delta S of system is equal to 2 into R into ln of 100 by 10, which is nothing but 2R ln 10. This is nothing but delta S of system is equal to 2R into 2.303. This is nothing but 4.606 R. Delta S of system 4.606, 4.606. I have in 2 we have this options. In that's question option number 1 and option number 3. So we have to check for delta S of surrounding. So delta S of surrounding, the expansion is taking place. R is universal gas constant. So since the expansion is taking place against vacuum, that with since there is no external pressure, so work done will be 0. Work done will be 0. So when work done is 0, change in internal energy is also equal to 0. So when change in internal energy is equal to 0, but first law of thermodynamics, we have delta U minus W, which is also equal to 0. So for surrounding also, heat change will be, there is no heat change in the surrounding. The entropy change of the surrounding will also be equal to 0. So which option is correct? Option 3 is correct for 84. Next, among the following option, the correct trend in the electron gain enthalpy is chlorine, fluorine, bromine, iodine. So option 2 is correct. The correct order of solubility of the salt, given salt in water is. So which one is more soluble? AgBr is more soluble because it's minus 13. KSP value is high. When KSP value is high, its solubility will be low. So AgBr, ZnOH twice, then comes 1 minute. It's 10 power minus 15. Hg2Cl2 is 10 power minus 18. So which one is having highest solubility in this one? ZnOH twice will be having highest solubility. Then comes ZnOH twice is in only one option. Option 3 is correct. Then comes AgBr, then comes Hg2Cl2. Consider the following reaction sequences and choose the correct option. C triple bond C with hydrogen palladium with Lindlar's catalyst. One forms cis isomer and another one will form trans isomer. So geometrical isomer formation takes place. Option 4. Next. The amount of carbon dioxide evolved on complete combustion of 116 gram of N-butane. Uh, Apply mole formula and calculate it. You will get 352 grams. Option 4. And second one, 89, sorry, 89. The number of, see here, we have to round off this one. Here 5. You have to look into previous number. If it is even, keep the number as it is. This one and this one we have. And next one is odd. If it is odd, increase the previous number by 1. So option 2 is correct for this. In potash alum, the ratio of K to SO4, K plus and SO4 minus is, what is the ratio of K plus and SO4 minus? It's not just K to SO4. Okay, it's not just K2SO4. Next, aluminium sulfate will also be there with that. So aluminium sulfate means Al2SO4 thrice. So total ratio will become 2 is to 4, 1 here and 1 along with SO4, 3 along with SO4, AlSO4 thrice. So it's 1 is to 4. That's nothing but 1 is to 2, which is in option 4. So this is the answer for all the questions, chemistry question. So when we get the proper PDF format, I'm going to post all the answers separately for this one. Okay, I hope all of you have done very well in the exam since the question paper was almost easy. So let's continue. All the best for your counseling results and counseling process. See you while solving the answers, complete answers.